Today, we will learn about the following tools required to construct geometric shapes. You must have seen these tools in your geometry box. Today, we will understand their importance in geometry. Let's first talk about this tool. We call it a ruler or the straight edge. If you look carefully, you will find markings on both sides. It has markings in centimeters along one edge and in inches along the other edge. Based on these markings, the ruler helps us to draw line segments and measure their lengths. Now look at this tool. There is a place to put a pencil. By placing the pencil, we get a pair. Pointer on one end and a pencil on the other end. We call it a compass. We use it to draw arcs and circles. By adjusting the compass, the distance between the pointed end and the pencil's tip is increased or reduced. Thus, the desired distance can be taken in a compass. With this, we use a compass to mark off equal lengths and to make perpendicular lines, but not to measure them. Now look at this tool. It is like a compass, but it has two pointed ends. We call it a divider. It is a pair of pointers used to compare lengths. We can also see two triangular pieces in the geometry box. One of these triangles has 90 degrees on one side and 45-degree angles on both the other vertices. And the other triangular piece has 30 degrees, 60 degrees and 90-degree angles at the vertices. There are signs in centimeter on the sides forming their right angles. We call them set squares. They are used to draw perpendicular and parallel lines. You must have seen this tool in your geometry box. Can you tell me what it is and how it is used? Think a little. Let me tell you. We call this a protractor. We use it to measure angles. It is a semicircular device and its curved edge is divided into 180 equal parts where each part is called a degree. The measure starts from 0 degrees on the right-hand side and ends with 180 degrees on the left-hand side and vice versa. We use it to draw and measure angles. Keep in mind, just as we measure the length in meters, the weight in kilograms, we measure the angle in degrees, which is denoted by this sign. So today, we learned about the following tools required to make geometric shapes. In the next video, we will see some examples related to them. Today, we will see some examples related to the tools used in geometry. Example 1. Explain. Opposite sides of a given quadrilateral are equal. The easiest way to find out is to measure the length of each line segment. To measure the length of any line segment, we need a ruler and a divider. Suppose we have to measure the length of the line segment AB. We will place one pointed end of the divider at point A and open the divider and place its other pointed end at point B. Now, maintaining the spread, place one of its pointed ends on the 0 mark of the ruler and find the other pointed end pointing to a mark of the ruler. For instance, Here the pointed end indicates 7. Since we have used symbols marked in centimeters for measurement, the length of the line segment AB is 7 centimeters. Using the same method, we know BC is equal to 3 centimeters, CD is equal to 7 centimeters, and DA is equal to 3 centimeters. Looking at the measurements, we can say that AB is equal to CD and BC is equal to DA. That is, the opposite sides of the given quadrilateral are equal. We can also measure the length with the help of a ruler, but we will have to take some precautions. For instance, we will place the ruler along line AB in such a way that the mark 0 is exactly on the point A. Then we will note the mark where point B is placed on the ruler. Keep in mind, while looking at the mark on the ruler, it is important to place the eye just above the mark. With this, we find that the length of AB is 7 centimeters. Example 2. Find the measurement of angle DBC using the protractor. If we look at angle DBC, we find that point B is the vertex of this angle and BD and BC are the sides of the angle. To find the measurement of the angle, we will place the protractor at an angle such that its midpoint overlaps vertex B and the line shown on its straight edge, which we also call the zero edge, completely covers any one side of the angle DBC. Like here, it completely covers line BC. Now here the protractor is placed correctly at an angle, so we can measure the angle. Can you tell us which scale will be used to measure the angle, inner scale or outer scale? Think a little. Absolutely correct. We have to choose the scale on which the inscribed 0 degrees is close to the second point C. Since the inner scale is close to 0 degrees centigrade, we will choose the inner scale. Now we see that the other side of the angle represents the 70th part of the inner scale. So the angle will measure 70 degrees. In this way, we can say that angle DBC is equal to 70 degrees. So today we saw some examples related to the tools used in geometry. In the next video, we will deal with some misconceptions related to them. Today, we will see common mistakes related to the tools used in geometry. Mistake 1. While drawing the shapes of geometry, students are advised to draw thin lines and mark points lightly. Thicker lines or bigger dots cause confusion and result in wrong measurements. For instance, with the thin line, we get the measurement as 11.5 centimeters, while a thick line and thick points will give us the measurement here 11.7 centimeters. Due to thick points, the dividers are not placed in the correct position, which gives us the wrong length of the line segment. Mistake 2. Some students don't keep sharpened pencils. Keep in mind, the more the pencil is pointed and sharp, the thinner the line will be and the less likely it is to make mistakes while constructing the shape of geometry. But if the pencil is not pointed enough, then the line will be thick, which will increase the chances of making a mistake while constructing a shape. Mistake 3. Students often use the same pencil for the compass and to draw lines. Keep in mind that if you have two pencils, one pencil will always remain fixed to the compass, and the other can be used to draw lines or curves and mark points, which will reduce the wear of the pointed end of the pencil, and at the same time, one can overcome the difficulty of placing and removing the pencils in the compass. Mistake 4. Students often try to find the measurement of a line segment by using a ruler without using a divider. But this is wrong, because when the eye is not placed just above the symbol, it results in wrong measurement. The pointed ends of the divider can be placed on the line segment and the correct mark of the line. This can help us avoid any mistakes in measurement. Mistake 5. The geometrical instrument compass is an English word which is similar to a magnetic compass. This confuses some students who believe that the compass of a geometry has some relation with the magnetic compass. This is a misconception and there is no relation between them. So today, we saw some common mistakes related to the tools used in geometry. Today, we will learn how to construct a circle when its radius is known. We see many things around us which are shaped like circles, like a clock, fan, wheel, etc. Sometimes it becomes necessary for us to construct their shape on a piece of paper. For example, if we want to make a paper watch, we have to draw a circle on a paper. Although we can easily construct a circle using some means such as a bangle, but with this we cannot construct a circle with the desired radius. We can construct a circle with the desired radius using the tools of geometry. In this video, we will learn how to draw a circle when the length of the radius is known. Suppose we have to draw a circle with a radius of 2.5 centimeters. Here, the radius of the circle tells us that the distance of any point on the circle from the center will be 2.5 centimeters. To draw a circle using the measurement of the radius, we need a paper, 2 pencils, a ruler and a compass, etc. First, we will attach a pointed pencil to the compass. Now let's draw a circle using the following method. Step 1. First, we will place the pointed end of the compass on the symbol 0 of the ruler, and opening the compass, we will place the pencil end on the required radius of 2.5 centimeters. Step 2. Using a sharp pencil, we will mark a point in the middle of the paper, which is the center of the circle, and name it as C. Step 3. Now, we will place the pointed end of the compass at the center C. We will find that the tip of the pencil has also reached a point on the paper. The distance taken should not change. Step 4. Now, we will keep the pointed end of the compass fixed at the center and rotate the tip of the pencil slowly to draw the circle and complete the movement around in one instant. From this, we will get a circle with radius 2.5 centimeters. Now, if you want to draw a circle whose diameter is 5 centimeters, how will you do it? Try it by pausing the video. Let me tell you. Diameter, as you know, is a line segment that connects any 2 points at the boundary of a circle through the center of the circle. That is, it is twice as long as the radius. We can say that the length of the radius is half the length of the diameter. Since, to draw a circle, the length of the radius is required, we will divide the diameter by 2 so that we know the measurement of the radius to be 5 by 2, which is equal to 2.5 centimeters. Therefore, whenever there is a question to construct a circle, it is important to note whether the measurement provided is of the radius or the diameter. Now, you will be able to draw a circle if you know the length of the radius. Today, we learned how to draw a circle when its radius is known. We will understand it more comprehensively with the help of some examples. Today, we will see some examples related to construction of a circle. Draw a circle with a radius 2.8 centimeters with center A. Here, the radius of the circle is 2.8 centimeters, which tells us that the distance of any point on the circle from the center is 2.8 centimeters. To construct a circle using the measurement of the radius, we will need a paper, 2 pencils, a ruler, and a compass. First, we will attach a pointed pencil to the compass. Now, let's draw a circle using the following method. Step 1. First, we will place the pointed end of the compass on the mark 0 of the ruler and open the compass for the required radius of 2.8 centimeters. Step 2. Using a sharp pencil, we will mark a point on the paper. This will be the center of the circle and we name it A. Step 3. Now, we will place the pointed end of the compass at the center A. Step 4. Now, we will keep the pointed end of the compass fixed at the center and rotate the tip of the pencil slowly and complete one round. From this, we get a circle with center A and radius 2.8 centimeters. Next example. With the circle formed in the previous example, can we construct another circle with the center B in such a way that each one of them passes through the center of the other? Can you answer this question? Stop the video and think about your answer. Let me tell you, the answer to this question is very simple. Suppose we take the center of the second circle at the boundary of the first circle and its radius will be equal to the radius of the first circle, that is 2.8 centimeters. So the center of the first circle will pass through the boundary of the second circle. Let's try to draw a circle based on this understanding. Step 1. First, we will place the pointed end of the compass on the mark 0 of the ruler and open the compass for the required radius of 2.8 centimeters. Step 2. Using a pointed pencil, we will draw a point on the boundary of the first circle. This will be considered the center of the second circle and we name it B. Remember, we can mark point B anywhere on the boundary of the first circle. Can you explain why? Think a little. Absolutely right, because any point taken from the center A to the boundary of the circle will be at equal distance. Step 3. Now, we will place the pointed end of the compass at the center B. Step 4. Now, we will keep the pointed end of the compass fixed at the center B and rotate the tip of the pencil slowly and complete one round. From this, we will get a second circle with center B and radius 2.8 centimeters. We can also see that the center of the first circle passes through the boundary of the second circle. Today, we saw some examples related to construction of a circle. In the next video, we will see some misconceptions related to construction of a circle. Today, we will see common mistakes related to the construction of a circle. Common mistake 1. When students are asked to draw a circle with a radius of 2 centimeters, then to construct a circle, they open the compass for the required radius. But while measuring the radius, instead of placing the pointed end of the compass on the symbol 0, they often place it on symbol 1 of the ruler. With this, the measurement of the radius in the compass is decreased by 1 centimeter. Students construct the circle using this measurement, due to which the circle formed is inaccurate. Keeping in mind that while measuring in the compass, it is necessary to keep the pointed end at 0. If the ruler is broken or the 0 sign is not visible properly, then we can place the pointed end on the other symbol, but then it is important that the distance from this symbol is measured properly. That is, if we place the pointed end on 1 and we need to open the compass for a required radius of 2 centimeters, then it is important that the tip of the pencil is placed on the symbol 3. If we place it on symbol 2, it will be wrong. Common mistake 2. Some students fail to place the pencil properly in the compass. Keep in mind that while placing the pencil in the compass, it is important to keep the pencil and the ends of the compass in a line by placing the compass vertically on a flat surface. Common mistake 3. Some students take the measurements given in the compass while constructing circles, but they fail to maintain the measurement while using the method to construct a circle. Keep in mind that if the distance taken in the compass changes, we will not get the desired circle. Often, this distance changes when rotating the compass. This does not give us the correct circle. Such mistakes can be avoided by maintaining the distances taken in the compass. Common mistake 4. Some students fail to draw a circle by rotating the compass just once. It becomes necessary for them to rotate the compass repeatedly to draw a circle. In such a situation, the chances of change in measurement taken in the compass increases, and as a result, the circle is drawn incorrectly. With practice, one can avoid such mistakes. Common mistake 5. Many times in the question, the length of the diameter is provided to construct a circle, but students misinterpret the information provided. They construct the circle assuming the given measurement to be the length of the radius and as a result obtain the wrong circle. Keep in mind that if the measurement of the diameter is provided, we must divide it by 2 and find the measurement of the radius. This will give us the correct circle. So today, we saw some common mistakes related to the construction of a circle.
Today we will learn construction of a line segment.
You know that a straight line connecting two points is called a line segment. Like here, by connecting point A and point B, we have drawn a line segment. We write its name as and read as line segment AB. Since the line segment starts at one fixed point and ends at another fixed point, its length is definite. This means that if we know the length of the line segment, then we can draw one. So, let's learn how to draw a line segment of the given length. Suppose we have to draw a line segment of 6.2 centimeter. Just think, can we draw a line segment of the measurement with the help of ruler? Give it a thought. Sure, we can draw it. Step 1. We will place a ruler on the paper and mark one point on 0 and another point on the point showing distance of 6.2 centimeter and name these points P and Q. You can name any point with capital letters of English. While taking measurement, make sure that you observe the line carefully and mark the exact point, otherwise there may be a mistake in the measurement. Step 2. We will connect the obtained points with a straight line. This will give us the line segment PQ. We have another method to draw a line segment in which we also use compass with ruler. So, let's understand this method. Suppose we have to draw a line segment of length 6.2 centimeter. Step 1. First of all, we will draw a line. We will name it line M. Then we will mark a point on the line and name it P. Step 2. Now placing the pointed end of the compass on 0, we will stretch the compass so that the end with the pencil reaches the sign indicating the distance of 6.2 centimeter. Step 3. Now we will place the pointed end of the compass on point P and make an arc cutting the line M. Keep in mind that the distance taken in the compass should not change under any circumstances, otherwise the construction will be wrong. Step 4. We will name the point where the arc intersects the line M as Q. Here we have obtained a line segment PQ of length 6.2 centimeter. Sometimes we need to draw a line segment of equal length. So, let's see how we can draw a line of equal length using a given line segment. To draw a line segment with the help of a ruler, we can find the measurement of the given line segment, and then using the method given above, we can draw a line segment of equal length. We can also make it using ruler and compass. Suppose we are given a line segment PQ and we have to draw a line segment with the same length. Step 1. We will place the pointed end of the compass at point P and opening the compass, place the end with the pencil on Q. That is, we will take the measure equal to line segment PQ on the ends of the compass. Step 2. Then we will draw a line which will be named M. Step 3. On the line M, we will take a point named point R. We will place the pointed end of the compass at point R and without changing the measure of the compass, draw an arc on the line M. Step 4. The point where the arc intersects the line M will be named S. Here we will get line segment RS whose length is equal to given line segment PQ. Now you must have learned how to draw a line segment.
Today we learned construction of a line segment.
In the next video, we will see some interesting examples based on the same.
Today we will see examples of construction of line segments.
Example. Draw a line segment of length 10.6 centimeter. Let us first draw the line segment using a ruler. Step 1. We will place the ruler on the paper and mark 2 points covering the length of 10.6 centimeter. Like here, we have marked one point on 0 and the other point on 10.6 centimeter mark of the ruler. Keep in mind to carefully observe the line. Step 2. We will connect the obtained points with a straight line. By giving the names P and Q to the points, we will get line segment PQ. We can also draw line segments using ruler and compass. Step 1. First of all, we will draw a line. We will name it line M. Then we will take a point on the line and name it P. Step 2. Now we will place the pointed end of the compass on 0 and stretch the compass so that the end with the pencil reaches the sign indicating a distance of 10.6 centimeter. Step 3. Now we will place the pointed end of the compass on point P and make an arc cutting the line M. Step 4. The point at which the arc intersects the line M will be named point Q. Here we have obtained a line segment PQ of length 10.6 centimeter. Next example. Draw a line segment whose length is the difference between the lengths of line segments AB and CD. Just think, here we do not know the measurements of both AB and CD line segments. So in such a situation, is it possible to find a line segment whose length is equal to the difference of both? Give it a thought. Let us tell you. Yes, it can be done if one understands geometry. Here we can see that the line segment AB appears to be longer than the line segment CD. To find the difference in their lengths, we subtract the lesser from the greater. So we will first draw a line segment measuring equal to the line segment AB. We will do it like this. Step 1. First of all, we will place the pointed end of the compass on point A and opening the compass, place the pencil on point B. That is, we will take the measure equal to line segment AB on the ends of the compass. Step 2. Then we will draw a line which we will name M. Step 3. On the line M, we will take a point which will be named point O. Placing the pointed end of the compass on this point, and without changing the measure of the compass, we will draw an arc cutting M. Step 4. The point at which the arc intersects the line M will be named Q. Here we will get line segment OQ, the length of which is equal to given line segment AB. Now we will draw a line segment of equal length of the line segment CD. We will do it as follows. Step 5. We will place the pointed end of the compass on point C and stretching the compass, place the end with the pencil on point D. That is, we will take the equal distance of the line segment CD in the ends of the compass. Step 6. Without changing the measure of the compass, we will place its pointed end on the point O on the line and make an arc cutting the line M. Step 7. The point at which the arc intersects the line M will be named point P. Here we get line segment OP, the length of which is equal to given line segment CD. Step 8. Here you can see that if we remove the part OP from OQ, then the obtained part shows the difference of the lengths of both. That is, OQ minus OP is equal to PQ. Since OQ is equal to AB and OP is equal to CD, so we can say that AB minus CD is equal to PQ. In this way,
We have drawn the line PQ as the difference between the lengths of AB and CD.
Can you draw two line segments and then construct a line segment whose length is same as sum of lengths of both the line segments?
So today we saw examples of construction of line segments.
in the next video,
We will see some mistakes one can make while constructing line segments. Today we will see some mistakes related to construction of line segments.
Mistake 1. Rahul made a line segment of length 5.4 cm using a compass and a ruler. When the teacher measured the length of this line segment, he found the length to be 5.3 cm. Find out what mistake Rahul may have made. Give it a thought. Some children do not take care to maintain the proper measurement of the compass. They do not use the compass carefully. Children take the given length in the compass but accidentally shake the sides of the compass. This often changes the measure taken on the compass. Rahul must have made the same mistake. Special care should be taken while using the compass so that the distance taken does not change. Mistake 2. Line segment can be drawn using only a ruler, but while drawing the line segment, children do not carefully observe the mark while drawing the line segment. Due to this, they do make the line segment, but it is not of the given measurement and thus it is wrong. Jay drew a line segment of 5 cm length. When Jay measured the line segment, he found its length to be 4.9 cm. This happened because while drawing the line segment, Jay was looking at the sign from the right. Jay once again tried to draw a line segment of length 5 cm, and this time the length of line segment was 5.1 cm. This time while drawing the line segment, Jay was looking at the sign from the left. Like Jay, some children are unable to draw a line segment of the correct measurement because these children do not carefully observe the mark while drawing a line segment. Therefore, while measuring length, it is important that we take special care in observing the mark. Mistake 3. Before using the compass, children do not take care that the length of both sides of the compass is the same. If it is not, then by adjusting the pencil, we must equalize the length of both sides of the compass. While adjusting the pencil, always make sure that the compass is closed, that is, that there is a minimum distance between the compass and the pencil. Mistake 4. Sometimes because of a flaw in the compass, the distance does not remain constant, and this is another reason why length of the line segment might be wrong. The flaw in the compass might be because sometimes the screw behind the compass is loose. The screw of the compass must always be tight. We can tighten this screw with the help of the key given with the compass. Therefore, it is necessary to check the screw periodically. Mistake 5. Some children keep in mind that the points should be very small. Similarly, the lines and line segments should also be thin. If the point is large, then the distance taken on the compass increases the probability of being wrong. At the same time, the probability of getting the line segment wrong also increases.
So today we saw some mistakes related to construction of line segments.
Today, we will understand what are perpendiculars and perpendicular bisectors and some methods used to construct them. First, we will understand what a perpendicular is. When two lines such as M and N intersect each other such that the angles formed between them are right angles or 90-degree angles, then they are said to be perpendicular to each other. We show it using symbols either this way or this way. Now see here, line N is perpendicular to line M, but this line is dividing M into two equal parts. That is, the perpendicular line N passes through the midpoint of the line M. We can say that the line N is the perpendicular bisector of the line M. For example, here we have a rectangular paper. Fold it down the middle lengthwise and make a crease. Let line AB be the crease of the paper. Fold the paper once again down the middle in the other direction and make a crease. Suppose we mark this crease PQ. As you can see, the two line segments are mutually perpendicular. Also, they pass through each other's midpoint. Therefore, line segment AB is perpendicular bisector of line segment PQ. Similarly, line segment PQ is the perpendicular bisector of line segment AB. Let us understand some interesting methods to construct a perpendicular passing through a point on a given line. Here, we have a paper on which a line M is drawn. We have to draw a perpendicular line which passes through point P on this line. For this, we will fold the paper in such a way that the crease passes through point P and one part of line M overlaps the other part completely. Once we open the paper, we will observe that the crease passes through P and it is perpendicular to line M, which means we have drawn a perpendicular passing through the point on the given line. Can we draw a perpendicular through a point on the given line using a ruler and a set square? Think for a while. Let me explain. The method is as follows. Step 1. A line M and a point P are given. Note that P is on the line M. Step 2. Place a ruler with one of its edges along M. Hold this firmly. Step 3. Place a set square with one of its edges along the already aligned edge of the ruler such that the right angle corner is in contact with the ruler. Step 4. Slide the set square along the edge of the ruler until its right angled corner coincides with P. Step 5. Hold the set square firmly in this position. Draw PQ along the edge of the set square. The line segment PQ is perpendicular to the line M, which we can show as this. We can increase the perpendicular with the help of a ruler. Today, we learned what are perpendicular and perpendicular bisectors and some methods used to construct them. In the next video, we will learn how to draw a perpendicular and perpendicular bisectors using a ruler and a compass. Today, we will learn how to draw a perpendicular and a perpendicular bisector using a ruler and a compass. In geometry, a ruler and a compass is often used to draw a perpendicular through a point on a given line. Let's understand this method. Step 1. Suppose we are given a point P on line M. Step 2. Place the pointed side of the compass on P. With P as center and a convenient radius, construct an arc intersecting the line M at 2 points E and F. Step 3. Next, we will place the pointed side of the compass on E and construct an arc with a radius greater than EP. Without changing the distance taken in the compass, we will draw another arc from F, which cuts the arc formed from E at point Q. Step 4. We will join the line PQ passing through point P and point Q. The line PQ is perpendicular to the line M. Now look here. We are given a line L and point A is not lying on the line. Just think, how can we draw a perpendicular to the line through this point? Let me explain. Here, we will use a ruler and a compass to draw a perpendicular. Step 1. We are given a line L and a point A which is not on it. Step 2. With A as a center, draw an arc which intersects line L at 2 points S and T. Step 3. Using the same radius and with S and T as centers, construct two arcs that intersect at a point, say B, on the other side. Step 4. We will join AB. Thus, AB is perpendicular to L. Now let us understand how to draw a perpendicular bisector of a line segment. To draw a perpendicular bisector of a line segment, we will use a ruler and a compass. Step 1. Suppose we are given a line segment AB of any length and we have to draw its perpendicular bisector. Step 2. Place the pointed side of the compass on A and draw an arc on both sides of AB whose radius is more than half the length of AB. Step 3. With the same radius and with B as center, draw another arc using the compass. Let it cut the previous arc at point J and K. Step 4. Join JK. It cuts the line segment AB at point C. Here, AC and BC are equal. Line JK divides line segment AB into two equal parts. Also, this line is perpendicular to AB. Therefore, we can say that line JK is the perpendicular bisector of line segment AB. Remember that you will open the compass for more than half the distance. If you open the compass for less than half the distance, the arcs will not intersect. Today, we learned how to draw a perpendicular and a perpendicular bisector using a ruler and a compass. In the next video, we will see some examples of perpendicular and perpendicular bisectors. Today, We will see some examples related to the construction of a perpendicular and perpendicular bisectors on a line segment. In the given figure, we have a line A and a point O not lying on the line. Draw a perpendicular through the point O to the line A. Using a ruler and a set square, draw a perpendicular line segment ON that passes through point O. Place a set square on A in such a way that one arm of its right angle aligns along with A. Next, place a ruler along the edge opposite to the right angle of the set square. Hold the ruler tight and slide the set square along the ruler till the point O touches the other arm of the set square. Join the line segment ON along the edge through O, meeting A at N. Now, line segment ON is the perpendicular line segment on line A. Next example. A line segment with length 5 cm makes a 30-degree angle with the horizontal line. Using a ruler and a compass, draw a perpendicular to the line segment ON which passes through point N. First, we will draw a horizontal line and mark point O on it. By placing the protractor correctly at point O, we will mark a point opposite 30 degrees centigrade. Next, we draw a ray starting from O passing through this point. Open the compass for the required radius of 5 centimeters. Placing the pointed end of the compass at O, we will draw an arc that cuts this ray and label it as intersection N. In this way, we have drawn a line segment ON which makes an angle of 30 degrees with the horizontal line. Using a ruler and a compass, let's draw a perpendicular to the line segment ON which passes through point N. Now, can you tell me how to do this? Think for a while. Let me explain. Step 1. Open the compass to a convenient radius. Place the pointed end of the compass on N. With N as a center, draw an arc that cuts ray ON on points E and F. Step 2. We will place the pointed end of the compass on E and with a radius greater than EN, draw an arc on one side of the ray. Without changing the compass setting, we will draw another arc from F, which cuts the arc drawn from E at point Q. Step 3. Join the line NQ, passing through points N and Q. The line NQ is perpendicular to the line ON. Next example. Draw a line segment PQ of length 7 cm and construct a perpendicular bisector using a ruler and a compass. Step 1. Draw a line segment PQ of length 7 cm. Step 2. Open the compass with radius more than half the length of line segment PQ and place the pointed end of the compass on P. With this radius, draw an arc on both sides of the line segment PQ. Step 3. Without changing the compass setting, place its pointed end on Q and draw an arc, cutting the previous arc at points R and S. Step 4. Join RS, passing through points R and S, which intersects the line segment PQ at point C. Line RS is a perpendicular bisector to the line segment PQ. Today, we saw some examples related to the construction of a perpendicular and perpendicular bisectors on a line segment. In the next video, we will see some common mistakes related to them. Today, we will see some misconceptions and simple mistakes related to the construction of a perpendicular and perpendicular bisectors on a line segment. Misconception 1. Look at the figure given below and find out which line segment is the perpendicular bisector of the other line segment. Some students fail to understand the concept of perpendicular bisectors properly. They believe that a perpendicular bisector is always vertical. With this understanding, they select option 2 as their answer, which is incorrect. Since here an angle of 90 degrees is formed in line segment RS and line segment PQ, and at the same time a line segment RS seems to divide line segment PQ into two equal parts. Thus, here line segment RS is the perpendicular bisector of the line segment PQ. Hence, option 1 is the correct answer. Line segment PQ is perpendicular to line segment RS, but it doesn't divide the line segment RS into two equal parts. Therefore, we cannot call line segment PQ as the perpendicular bisector of line segment RS. Now let's understand some simple mistakes that are made while constructing a perpendicular and perpendicular bisectors. When students are asked to find the perpendicular bisector of a given line segment AB, they don't consider it important enough to take more than half the length of the line segment in the compass during the construction. Mistake 1. They take less than half the length of the line segment in the compass and place its pointed end on A and draw an arc on both sides of the line segment. Then, they place the pointed end of the compass on point B and attempt to draw an arc. But since less than half the length was taken in the compass, they fail to draw an arc intersecting the previously formed arc. Mistake 2. To draw an arc, they increase the length taken with the compass and construct an arc intersecting the previous formed arcs. With this, they get a perpendicular, but it is not the bisector of the line segment AB. The correct understanding is that we need to take more than half the length of the line segment with the compass to draw an arc from both points of the line segment without changing the compass setting. This gives the desired perpendicular bisector. Today, we saw some misconceptions and simple mistakes related to the construction of a perpendicular and perpendicular bisectors on a line segment.
Today we will learn how to construct a copy of an angle. We have learned how to construct an angle according to the given measurement with the help of a protractor and compass. Today we will learn the method by which we will be able to make an angle equal to an angle whose measurement is not known to us. Let us understand this method. Suppose we are given angle PQR whose measurement we do not know. We have to make an angle of measurement equal to this angle. Step 1. To draw the angle, first draw a ray ST. Step 2. Place the pointed end of the compass on the top point Q of angle PQR. Next, open the arms of the compass at a convenient distance and draw an arc cutting the arms of angle PQR at points E and F. Step 3. Let the distance taken in the compass remain intact. Keep its pointed end at S and the ray ST and draw an arc cutting at point J. Step 4. Now place the pointed end of the compass at point E and open the compass for the distance from E to F. Step 5. Without changing the distance of the compass, place its pointed end at point G and draw the arc cutting the previous arc at point R. Step 6. Now we will add vertex S and point R and draw ray SR. This will give us angle RST, which is equal to angle PQR. So today we have learned how to construct a copy of an angle. In the next video, we will see some interesting examples related to it. Today we will see examples of constructing angles equal to a given angle. Draw an angle of measurement equal to angle A. Here, we are given angle A whose measurement we do not know, and we have to construct an angle of measurement equal to this angle. In the previous video, we learned the method. Do you remember? Think for a while. Let us tell you. Step 1. To draw the angle, first we will draw a ray JK. Step 2. Taking the compass, we will place its pointed head on vertex A. Then, we will open the compass for a convenient distance and draw the arcs intersecting the sides of the angle A at points R and F. Step 3. Now we will take the point J at the top and place the pointed end of the compass on J and draw an arc without changing the distance, which will intersect JK at point O. Step 4. Now we will place the pointed end of the compass at point R and open the compass for the distance from R to F. Step 5. Without changing the distance of the compass, we will place its pointed end at point O and draw the arc cutting the previous arc at point P. Step 6. Now, we will connect point J to the point P and draw the ray JP. This gives us angle J, which is equal to angle A. Next example. Construct an angle measuring 110 degrees. Make an angle equal to this angle with the help of ruler and compass. Here, we have to make an angle of measurement of 110 degree. We know the measurement of angle, so will we be able to make angle from the given measurement? Think for a while. Absolutely right. We have seen this in a previous video. Let us go through it and make an angle of 110 degree. First, we will draw a ray of any measurement. Name it BC. Here, we will use the protractor. Now, we will place the protractor on the ray BC as if the center of the protractor is on the point B and the zero edge is along the ray BC. As we have to measure 110 degree here, we will start from 0, which is close to point C. Now, we will mark a point in front of 110 degree and name it A. Then, we will join the point A and point B. This gives us the angle ABC of measurement of 110 degree. Now we have to make an angle equal to angle ABC with the help of ruler and compass. Step 1. Draw line A and mark a point F on it. Step 2. Now we will draw an arc by placing the pointed end of the compass at point B, which will cut the sides of angle ABC at points X and Y. Step 3. We will then place the pointed end at point F without altering the width of the compass and draw an arc that cuts the line A at point G. Step 4. Now we will take the distance equal to XY in the compass. Step 5. With this distance, we will place the pointed end of the compass at point G and draw another arc which will cut the previous arc at point E. Step 6. After this, we will join the pointed F and E and create a ray named FE. Now we have got angle EFG, which is equal to angle ABC. If we place the protractor at angle F, we will see that the measurement of angle EFG is also 110 degree. This verifies that angle EFG created is equal to angle ABC. So today, we saw examples related to constructing an angle equal to a given angle. In the next video, we will understand some of the mistakes related to this. Today we will see some misconceptions related to constructing an angle equal to a given angle. Many children make large-sized points. Because of the size of the point, it becomes difficult to take accurate measurements as the pointed end of the compass is not accurately placed. As a result, the angle of measurement is wrong. Therefore, the point size should be small. You must remember that a dot is a subtle sign that represents a place or position. We cannot make fine marks with a blunt pencil, but we can make a very small point using a pointed pencil. Keep in mind that the smaller the point, the more precisely the pointed end of the compass can be positioned. And then, the probability of making a mistake is reduced when making the angle. So whenever you draw a point, make it small. There are some important things we should keep in mind regarding the use of compasses, such as the pointed arm of the compass and the arm of the pencil must be equal in length. The screw of the compass should be tight so that the distance taken does not change. The pencil should also be fixed properly in the compass so that it does not slide while drawing an arc or circle. In order to draw a circle, this part of the compass is held between the forefinger and thumb of the same hand in this way. Then, the circle is drawn by rotating the compass slowly. Keep in mind that the compass must be precise at a certain point, and while drawing an arc or circle, the compass should not be moved from its fixed position and special attention should be paid to it. Now, let us look at the mistakes related to change in the width of the compass. At times, compasses are not used with caution. Some children take measurements at the ends of the compass properly. But while drawing the arc, the children do not take care that the measurement of the compass may change due to the high pressure. When children try to make angles using compass, they often get an incorrect measurement of the angle because of this mistake. Unsharpened pencil. It is necessary to use a pointed pencil to create any angle. If the pencil is not pointed or blunt, then the points and lines become thick, which increases the likelihood of the angle being wrongly measured. At the same time, neatness is not found in such an angle. Today, we saw some misconceptions related to constructing an angle equal to a given angle. Today we will learn how to bisect a given angle. We have a piece of cake here. Just think, how will we divide it into two equal parts? Think for a while. You are absolutely right. We will cut this piece in such a way and divide it into two equal parts. Now, look at this line. This line divides the given angle into two equal parts. We will call this line the bisector of this angle. In this video, we will learn how to bisect an angle. Suppose we have to bisect the angle on a paper. Then, we will place the sides of the angle exactly one above the other so that it forms a crease on the paper. This crease on paper, formed after unfolding the paper, divides the given angle into two equal parts, so it acts as the bisector of this angle. To obtain the bisector of an angle, we use the tools of geometry. We can obtain the bisector of an angle with the use of a ruler and a compass. So, let's understand the method. Let's see how we can construct the bisector of angle AOB using this method. Step 1. First, we will consider O as the center. By placing the pointed end of the compass at the center O, we will open the compass to take an appropriate radius and draw an arc cutting both the arms of angle O. Suppose this arc intersects the arms of angle O at point M and point N. This is an initial arc. From the initial arc, we obtain two such points which have equal distances from the vertex. For instance, M and N are at equal distance from the vertex O. Step 2. Now we will place the pointed end of the compass at point M. We will increase the radius of compass as per the requirement. Then we will draw an arc in the interior of angle O. Step 3. Without changing the compass setting, we will place its pointed end at a point N and draw another arc cutting the arc formed from M. Assume both arcs intersect at point D. Step 4. Now, we will draw ray OD from the vertex O. Ray OD is the bisector of angle O. If we find the measurements of both angles using a protractor, then we will observe that both angles measure the same. This verifies that ray OD is the bisector of angle O. Today we learned how to bisect an angle. In the next video, we will see some interesting examples. Today we will see some examples related to the construction of the bisector of an angle. Draw an angle measuring 140 degree and bisect it. To draw an angle measuring 140 degree, first draw a ray. Let's name it BC. Now place the protractor on the ray BC in such a way that the center of the protractor is at point B and the zero edge completely covers the ray. Then we will use a protractor scale whose 0 degree is close to C. Since we have to draw an angle of 140 degree, we will proceed on this scale to find the sign representing 140 and mark a point in front of it. We will name it A. Now taking point B as the vertex, we will draw a ray which passes through point A. From this, we will get angle ABC which measures 140 degree. Now, let's bisect it. Step 1. To bisect the angle, draw an arc by placing the pointed end of the compass at the center of angle ABC, that is, point B which cuts the arm BC of angle ABC at point E and the arm BA at point F. Step 2. Place the pointed end of the compass on E and open the compass to take a radius more than half the length of EF. With this radius, we will draw an arc in the interior of angle ABC. Step 3. By keeping the same radius in the compass, we will place the pointed end of the compass on F and draw another arc that intersects the arc made from E. Both arcs intersect at point G. Step 4. Now we will draw ray BG from vertex B to G. The ray BG divides angle ABC in two equal parts, so it is the desired bisector. To verify this, we will measure both angles with the help of a protractor. The measurement of both angles is equal. With the help of a trace paper, if we draw the exact copy of one of the two angles obtained and place it over the other angle, then the arms of both angles coincide with each other completely, which proves that both angles are equal. This verifies that we have properly bisected the angle measuring 140 degree, giving us two angles and each of them measuring 140 degree by 2 is equal to 70 degrees. Next example. With the help of a ruler and a compass, construct an angle measuring 1.5 times of angle XYZ. At first, this question may seem difficult, but with the correct understanding of the composition of an angle, one can easily solve this question. Here we have to draw an angle 1.5 times larger than the given angle. 1.5 means 1 plus half. If we draw an angle equal to the given angle and then bisect one of the two angles, then we get one full angle and one half angle, which together will form an angle 1.5 times larger than the given angle. Let us understand this by constructing an angle. Here, angle XYZ is given to us. If we have to construct an angle of equal measure, how will we do it? Pause the video and recall the method to construct an angle measuring equal to the given angle. We will tell you. Step 1. Using a compass, we will place its pointed end at the vertex y. Then, we will open the compass to take the required radius and draw the arcs intersecting the arms of the angle y at points u and v. We will make this arc bigger so that we can proceed with the next step. Step 2. Here, we will keep arc xy common in both angles. Now, taking the distance of uv, we will place the pointed end of the compass at point v and draw an arc cutting the first arc. Suppose that both arcs intersect at point D. Step 3. Now we will draw the ray YD starting from the vertex Y and passing through point D. We obtain angle XYD, which is equal to angle XYZ. Now we will find the bisector of any one angle. Here, we will find the bisector of angle XYZ. Step 1. First of all, we have to draw an arc from vertex Y which intersects both sides of angle XYZ. Here we have already made an arc. We will use the same. Step 2. Placing the pointed end of the compass at point U and open it for more than half the distance of UV. With this radius, we will draw an arc in the interior of angle XYZ. Step 3. By keeping the same radius in the compass, we will place the pointed end on V and draw another arc cutting the arc made from U. Both arcs intersect at point M. Step 4. Now we will draw the ray YM starting from vertex Y and passing through M. Ray YM divides angle XYZ in two equal parts, so it is the desired or required bisector. Now if we add angle XYD and angle XYM, we get angle DYM, which is 1.5 times larger than angle XYZ. Next example, if we bisect a right angle, what will be the measure of each angle? We know that right angle means 90-degree angle. If we bisect this angle, we will get two equal parts. Since both angles are equal, each angle will measure 90 degree by 2 is equal to 45 degrees. Today we saw some examples related to construction of bisector of an angle. In the next video, we will see some simple mistakes related to it. Today we will see some mistakes related to the construction of bisector of an angle. Mistake 1. Some students fail to understand the basic method to find the bisector of an angle. So, instead, they use a protractor to measure the angle and mark a point at half of this measurement. Then, they draw a ray passing through the vertex at this point. They find it difficult to understand how to construct bisectors using compass. Therefore, they try to avoid using this method to find a bisector. It is important to have an understanding of the usage of compass to create bisectors. Suppose we have to find the bisector of an angle of 63 degree. Half of 63 degree is 31.5 degree. It will be difficult to identify it on a protractor accurately. In such a situation, we can find the bisector easily and accurately by drawing an angle of 63 degree and creating a bisector using the compass. Mistake 2. Sometimes, when finding the bisector of an angle, students draw an arc cutting the sides of the angle, but make mistakes while going forward with the method. For instance, to find the bisector of angle ABC, students make such an arc which intersects BC at D and AB at E. Then they place the compass on D and draw another arc in the interior of angle ABC. In the same way, they try to draw an arc by placing the pointed end of the compass on E. Here they can see that the arc formed from E will not intersect the arc formed from D. So, they change the distance of the compass and draw an arc intersecting at point F. Then they construct ray BF and show that BF is the bisector of angle ABC. Can you tell what went wrong here? Think for a while. You are absolutely right. It is wrong to change the measurement of the compass here. Keep in mind,
When you make an arc cutting the arms of the angle,
then take more than half the distance of DE in the compass. This will allow you to draw arcs cutting each other from both intersection points. Mistake 3. Some students fail to understand
why is it necessary to take more than half the distance of the intersection points as radius?
after drawing the initial arc that cuts the angle ABC. Keep in mind, this is necessary so that the two arcs formed
From the points of intersection of the arms,
intersect each other in the interior of the angle. If the distance is kept less than half, the arcs will not intersect. So today we saw some mistakes related to the construction of bisector of an angle.
Today we will learn to draw angles of given measurements using paper folding and protractor.
Let's learn it in an interesting way. We will draw a circle on the paper using the compass and cut it accordingly. Do you remember that the circle is an angle of 360 degrees? If we fold the circle in half, we will get an angle of 180 degrees. If we again fold it in half, we will get an angle of 90 degrees. Just think, if we again fold it in half, what angle will we get? Think. Yes, we will get an angle of measure 45 degrees if we open the circle. We will see that the circle is divided into 8 parts of 45 degrees each. Can you tell from the 3 sections what will be the measurement of the angle we get? Think. Exactly. We will get an angle measuring 135 degrees. Similarly, which measure of angles can be made using this method? We also use the protractor to draw angles. One block of protractor shows a measurement of 1 degree. Since there are sections from 0 to 180 degrees on the protractor, we can easily draw angles up to 180 degrees. Let's learn the method of making angles using the protractor. Suppose construct an angle of measure 122 degrees. Step 1. First, we draw a line MN. Step 2. By placing the center of the protractor on M, we will adjust the protractor in such a way that its zero edge line is along MN. Step 3. You can see that there are 2 scales on the protractor. Can you tell which scale do we need to see? Think. Absolutely right. We will see the scale at which 0 degree is near the point N. That is, here we will see the inner scale. In this way, we will consider line MN as 0 degrees. Moving forward on this scale, we will see at which place the section 122 degrees falls. We will mark the point L in front of this place. Step 4. Now we will draw a line starting from point M and going to point L. Thus, here we have created the angle LMN measuring 122 degrees. Now you pause the video and create an angle measuring 97 degrees. You will definitely be able to do it.
Today we learned to draw angles of given measurements using paper folding and protractor.
In the next video, we will see how to make angles of special measurement using compass. Today we will learn construction of angles of specific measure using a compass. You already know that compass is used to draw circles and arcs. Can we also draw an angle using it? Think. Let us tell you. Suppose we drew a circle of any radius with the help of compass and named its center O. Now we will draw diameter PQ on the circle. By keeping the distance taken in the compass, we will place the pointed end of the compass on P
and mark an arc cutting the circle.
We will name the point of intersection as K. Then we will connect K to the center O.
By placing the pointed end of the compass at the point K, again we will mark another arc by cutting the circle and give the name of the intersecting point C.
And then we will connect C to the center O. If again we place the pointed end of the compass on C and draw an arc, then this arc will cut the circle at the point Q only. What does this tell you? Think. Let us explain. Here all three arcs are equal, so the angles forming them are also equal. Diameter represents a measurement of straight angle that is 180 degrees. But it is also the sum of these three equal angles. So here the measurement of each angle will be 180 degrees divided by 3 is equal to 60 degrees. So, will you be able to think of any method of drawing angle of 60 degrees measurement of using compass? Think. Let us tell you. Step 1. We will draw a ray OP. Step 2. Now we will take the compass and place its pointed end on O. By taking a convenient radius in the compass, we will draw an arc that cuts the beam OP at point A. Step 3. By keeping the distance taken in the compass, we will place its pointed end at A and draw another arc cutting the received arc. We will name the received intersection point K. Step 4. Now we will draw a ray going from K to OK. The obtained angle POK measures 60 degrees. We can verify this using the protractor. Can you draw an angle of 30 degrees with this method? Think. Let us tell you how to draw it. We can bisect an angle of 60 degrees and make an angle of 30 degrees. Let's see its method. With the above method, we will make an angle of 60 degrees. Angle POK. We will draw arcs cutting each other from A and K by keeping the same distance taken in the compass. We will name the point of intersection of arcs D. If we draw ray OD, it divides angle POK into two equal parts. Thus, we have obtained two angles, angle KOD and angle DOA, by bisecting angle POK. That means each angle is 60 degrees divided by 2 is equal to 30 degrees. Now we will see how to construct angles of 120 degrees and 90 degrees. Step 1. We will draw a ray OP. Step 2. Now we will take the compass and place its pointed end on O. By taking a convenient radius in the compass, we will draw an arc that cuts the beam OP at point A. Step 3. By keeping the distance taken in the compass, we will place its pointed end at A and draw another arc cutting the received arc. We will name the received intersection point as K. Repeating the same, we will place the pointed end of the compass on K and draw another arc cutting the earlier arc. We will name the received point of intersection as C. Step 4. Now if we draw a ray OC starting from O, then we will get the angle POC, which will measure 120 degrees. We can verify this using the protractor. Step 5. To make an angle of 90 degrees, we will draw arcs cutting each other from C and K. The intersection point obtained will be named G. Step 6. Now if we draw a ray OG starting from O and going through G, then the measurement of obtained angle POG will be 90 degrees. We can verify this using the protractor. Now try to make an angle of 150 degrees using this method yourself.
Today we learned how to construct angles of specific measure using a compass.
In the next video, we will see examples related to making angles of given measurement. Today we will learn examples related to construction of angles of given measure. Example 1. Construct an angle of 23 degrees using a protractor. Step 1. Draw a ray AB. First, we will draw a ray AB. Step 2. By placing the center of the protractor on A, we will adjust the protractor in such a way that its zero edge is along the line AB. Step 3. You can see that there are two scales on the protractor. Can you tell which scale we need to take? Think. Absolutely right. We will see a scale on which 0 degree is near point B. In this way, we will consider line AB as 0 degree. Moving on this scale, we will see at which place 23 degree section falls. We will mark point C in front of this. Step 4. Now we will draw a line AC starting from point A and going from point C. Now we have constructed the angle CAB measuring 23 degrees. Example 2. Using a compass, draw an angle on the paper which is equal to the angle formed in the clock at 3 o'clock. When the clock strikes 3, then the big needle on the clock is at 12 and the small needle is at 3. In this way, the two needles form a right angle. The right angle, that is 90 degrees angle. That means we have to construct an angle measuring 90 degrees using a compass. So let's see how we can make it. Step 1. We will draw a line MN. Step 2. Now we will take the compass and place its pointed end on M. By taking a radius in the compass, we will draw an arc that cuts the beam MN at point Q. Step 3. Keeping the distance taken by the compass, we will keep its pointed end at Q and draw another arc cutting the obtained arc at point P. Repeating the same, we will place the pointed end of the compass on P and draw another arc cutting the earlier arc at point B. Step 4. By keeping the same distance in the compass, we will now draw arcs cutting each other from B and P. The intersection point obtained will be named G. Step 5. Now we will draw a line MG which will start from M and will go till G. Then we will get angle NMG whose measurement is 90 degrees. So today we saw examples related to construction of angles of given measure. In the next video, we will see some mistakes related to them.
Today we will see mistakes related to construction of angles of given measure. Mistake 1. Not using the protractor properly. Some children do not understand how to use protractor properly. They make mistake while making the angle of the given measurement. Then they put the protractor, but they don't know that the center of the protractor is at the top of the angle, and the zero edge of the protractor is thus along the beam. This will lead to an incorrect measurement of the angle. Keep in mind that the center of the protractor should be at the top of the angle and the zero edge of the angle should be along the beam, and only if then we get the right angle. Scale is often drawn on both directions of the protractor. Some children get confused by seeing two different scales marked on the protractor and think which of these scales to use. And in confusion, some children use the wrong scale, which gives them the wrong angle. Let's figure out an easy way to avoid this confusion. As you know, a right angle measures 90 degrees. In this way, the right angle appears as L. If the angle given to you is greater than this angle, then we will choose the scale of the protractor, which represents an angle greater than 90 degrees. Like here, we see that the angle will be more than 90 degrees. So we will choose the inner scale protractor here because the inner scale shows an angle greater than 90 degrees. Similarly here, we also see that the angle will be more than 90 degrees. But here we will choose the outer scale of the protractor because here on the outer scale we get an angle greater than 90 degrees. If the given angle is smaller than 90 degrees, then we will choose a scale that appears an angle smaller than 90 degrees. Like here, we see that the angle will be smaller than 90 degrees. So, we will choose the inner scale of the protractor because the inner scale shows an angle smaller than 90 degrees. Similarly, here we also see that the angle will be smaller than 90 degrees. But here, we will choose the outer scale of the protractor because here, on outer scale, we get an angle smaller than 90 degrees. With this understanding, you can remove the confusion related to choosing the scale. Mistake 2. Mistakes in the use of compass. Some children ignore some important things related to compass, which is why they make mistakes in the construction. Let us understand these mistakes. Children do not care to keep the distance taken in between the compass. It is same distance taken, while drawing the angle changes due to the pressure on the compass and thus becomes an incorrect angle. To avoid this, use compass carefully. You can also check the distance taken in compass periodically. In this, while drawing an arc or drawing a circle, children are unable to keep the pointed end fixed at one place and it slips. This causes a wrong arc. You can avoid this mistake by drawing an arc and circle from the compass over and over again for practice. So today we saw mistakes related to construction of angles of given measure.